Hello guys, welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI MStat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT JAM MS, ISI MStat, and CMI MSC Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Okay, so how do you show something is 1-1? Basically, you need to show that
the function is increasing, I guess, for 1-1.
Yeah, it is.
We can show that that if the function is increasing, then it's 1-1, right?
Yeah, of course you can say that.
Yes.
So
we have to take two functional values, two different functional values.
you can do that as well.
Sorry?
You can do that as well. So you just take two values, random values, I, and then you show that. So this is what you're talking.
We have to show that if f of x, actually.
Yeah, you can show this one as well. But the take here is I won't be doing this this particular one. It's kind of handy when you have a very simple function, or I don't know if you can do this. But I'll use calculus to prove it's 1-1. So you have f of x. I hope you have all written the value of f of x. No, I forgot the value of f of x. Anyway, something like
log x sec x plus tan x to the power whole cube.
Okay, thank you so much. Yeah. This one, right? Yeah.
Yes.
Now just differentiate. I mean, it's simple. It will be let's do. There is a cube here, so 3 log sec x plus tan x whole square times
1 by sec x plus tan x.
Yeah.
And then sec x tan x plus sec square x. Okay.
Yeah. It's pretty long, but okay. So let's say
That only sec x will be left, I guess. That taking common from this second term, sec x tan x plus sec square x, and then this whole term will be cancelled.
right. Yeah. This will be here. Now my point is I want to show this f dash x is is either greater than 0 or less than 0 or equals to 0. Where, I mean, what's the scene? I want to show this. The thing is, function log looks something like this, right?
Yes.
Uh, wait,
So power.
this power is inside, and there might be a case that so log of some positive number is
Yes.
still, yeah,
Uh,
right. Sorry about that. The power is outside. So
And
now the question is,
sec x.
excuse me.
And then for sec x, we have to just think through.
I mean, yeah, it's simple.
you have
Sec
to
x
find
is.
range.
I
Sec x will
mean,
also be from minus pi by 2 to pi by 2. It will never be negative.
yeah, it's
So
simple. I
Exactly
mean,
like
so it's positive.
cos x. Considering the case of cos x, it will always be positive for minus pi by 2, pi by 2.
yeah. So just
So then it is an increasing function.
yes. It's an increasing function indeed. So it's an increasing function, but it's 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 good to understand why an increasing function shows that it is 1 1.
Yes, that I'd like to see.
Yeah. So up till here, everyone is clear, right? So let's see why this increasing function means. It's simple. I mean, you all need to start with the basics. How do you define an increasing function? So when I say increasing, okay, there's one more question. Can it be, is it strictly increasing or it's not strictly increasing?
This
Sir, it
is,
is not strictly increasing.
yeah,
Strictly, it will be not strictly, yeah.
because there
Value
are
can be
situations where it will be
0.
0,
At zero.
at least f dash of x.
Mm-hmm.
Strictly increasing would be when it is
Strictly
greater than
increasing,
0.
strictly increasing is greater than 0.
Yeah.
Or something that is not strictly increasing is we call it non-decreasing. So non-decreasing means greater than equals to 0. So which one is the case? Because it's important. We'll see how, why.
So because you have, but then minus pi by 2 to pi by 2, it's not
Sir,
a
strictly
closed
increasing.
interval, right? If
Excuse me?
so,
Sir,
if
it should be strictly increasing.
the x value which we have,
Mm-hmm.
if we go to it's not closed, it's open interval, right? The brackets which you have in the start of the question.
Yeah.
So that means it does not actually ever become 0 for sec. Now I don't know whether log sec x plus tan x can be equal to 0 or not, but at least sec x will not be equal to 0 if you are having this domain, right? Because when it won't ever reach 0. It will be close to 0, but it won't be 0.
Okay. So let me explain what you said. The thing is, for this to be strictly increasing or non-decreasing, for this to be non-decreasing, it's important that strictly increasing, sorry, it's important that sec x is greater than 0. First thing,
Yes.
because there is a square here, it's always positive. So sec x is equals to 0. That means
That x would have to be pi by 2 or minus pi by 2.
right. But
Oh,
this is
wait.
not the case.
Oh, that's for cos x.
Yeah.
Or sec x is the opposite end.
Yeah. But the thing is, in the question, these points are not there.
Correct. So then there wouldn't be a situation where,
So there wouldn't be a situation where, the sec x is positive. Sorry, equals to 0.
yeah.
Now it's important. Now we see this log thing. I'll do it in the same page. I'll just erase it because it's difficult to keep track of the things right in the next page. So when will this term be zero? This term can only be zero when, say for example, I say this whole term as some h of x.
1.
Excuse me.
So sorry. And that sec x plus tan x term is 1. This whole term.
Yeah.
Then it can be 0.
Yeah. So h of x is 0 if and only if sec of x plus tan of x is equals to 1. Okay. So from here you can say that 1 plus sin x by cos x equals to 1. By the way, this symbol is called if and only if. I mean, it means that it's true both the ways around. It's either true from left to right, and it's also true from right to left. So 1 plus sin x is equals to cos x. So this is 0 at those points in the interval minus pi by x satisfies this property. 1 plus sine of x is equals to 1 plus equals to cos of x.
So wouldn't it be when x is equal to 0, that's 1. So if you have minus pi by 2 to pi by 2, the only situation where it is 1 plus sine x equals to cos x is when x equals 0, right?
Yeah, I mean, how do you prove it?
To prove it.
Sir, by looking at the graph.
Exactly. You can look at the graph. Proof as in how do you show that 0 is unique? There is no other value. A graph is the best way of representing, looking at it. It's something like, let's check. 1 plus, so what's cos x? Cos x is something like this. At 0 it will be 1.
Yeah.
It will be something like this.
And sine x is the opposite way.
Yeah.
It'll intersect at 1 by root 2 or something.
This is how sin x looks. So you're lifting sin x with 1. So the argument of 1 plus sin x gets lifted up by 1. So what it means is, so I'm trying to draw the graph of 1 plus sin x. It's called scaling. The point here will get raised up here. Here will get raised up by 1. All the points will go up by 1.
Yeah, so then it will intersect cos x at x equals 0.
Yes. So if you lift the whole this curve by 1, you can just imagine it will look something. So this point will be here, and this curve will be parallel to this curve. It will look something like something like this.
Okay.